This type of question sometimes gets a little difficult to solve by the method of substitution, because here neither you can suppose x, neither you can suppose root x. Because if you suppose x as a new function t as a x, then the derivative will be 1, and still you cannot, it will be like t minus under root t, but still you cannot solve by the method of substitution. Similarly, if you suppose root t, then also you cannot. So in such cases, if you see nothing, means none of the term containing variable is having the derivative in the question itself, neither this is having derivative here nor this is having derivative here. So in this case, what can we do? Means we have to rearrange the question itself. We have to work on the question. We have to simplify the question itself if such situation is present. What is that condition? You have to work in the question itself. Yes, if the variable containing term is not having the derivative itself in the question, alright, that time we have to work out in the question itself. We need to simplify that, and I'm going to simplify it. How? See, nothing I can do except rationalizing or converting this x as a x is actually root x times root x. So that's what I'm gonna do it here. So 1 divided by root x times root x minus root x, and this delta x. So from here I can take 1 over root x common, and I will get 1 divided by root x minus 1 dx. Alright, and why I did so, because I know that the derivative of root x, derivative of root x is 1 by 2 root x. Alright, because I have 1 over root 2x. This 2 it's not present here, but you can make it present by dividing by 2 and multiplying by 2. That's not a big issue. Alright, that's what I'm saying. So now we'll be simply taking this quantity as a t. Alright, because I already told you, when you have a free variable and a variable with some plus minus some constant, then that time always we choose the variable with some plus minus. Alright, so this will be our t, because if you suppose this, you won't get these things, the derivative of this present here. You must have to choose this one as a new function t. Alright, so that's root x minus 1. Now dt over dx, derivative of x to the power 1 by 2 with respect to x minus derivative of constant, that is 0, and it's a power 1 by 2, and whatever the power, that will get reduced by 1. It's a power rule of derivative. Alright, and that's 1 over 2 root x, because power rule having here, let me do 1 by 1. Why I'm doing this derivative again? Oh my god, you might get bored. 1 by 2, and finally I'm going to get 1 over 2 root x. Alright, so what I get here, that dt over dx is 1 over 2 root x. Let me first write it. Dt over dx as 1 by 2 root x. Okay, but in the question I have only 1 over root x. Alright, I'm just rearranging the question. It's 1 over root x minus 1 times dx, and what about this root x? Root x is coming down, so this particular thing I can make it here happen. So see how it's dt, twice of dt, this 2 is multiplying here, and this dx is coming here, so it will be now dx over root x. Alright, so this relationship I'm going to use it here, so my integral will convert something like this. See, 1 over whatever this is, 1 over root x minus 1 I had supposed as t, so 1 over t times dx over root x. Dx over root x, that is 2 times dt. Alright, 2 times dt. Okay, and what I'm doing, instead of writing 2 times dt, I'm writing here dt here and 2 here. That's the same thing. And the next step, I was about to do that, but why to take more time? And integration of 1 over t, that's simply log of absolute value of t plus some constant. The 2 will multiply that constant, and again you'll get 2c, and 2c is again a constant, so I'm not going to write that. So it's 2 times now. Okay, be happy. I'm just making 2c. Okay, so now 2 log absolute value of t. I'm just going to replace the value of t. T is what? Root x minus 1. So it's root x minus 1. Okay, plus again 2c is a constant, so let me write down constant. Okay, now happy, and this is the solution. That's it.